All right, so get this. We're diving into AI that's not just, spitting out answers. It's actually trying to think like us.
Oh, wow.
Researchers at Beijing Jiaotong University are working on something called O1 Coder.
Oh, my.
And you're going to want to hear this.
Yeah, this sounds really interesting.
So,
What they're doing is they're taking the system 2, thinking we see in OpenAI's O1 model, and they're teaching it to code.
okay, so back up for a second. System 2, that's the slow, deliberate thinking we do when we're solving a really tough problem, right?
Exactly. It's not the instant gut feeling system 1 thinking.
Right.
This is about logic planning,
Uh-huh.
the kind of thinking that goes into building like a website or an app.
So these researchers are basically trying to make AI think like a programmer.
Yeah.
That's ambitious.
Yeah, it is.
What makes O1 Coder different from other attempts to replicate O1 like G1 or LlamaBerry?
Well, they're really focused on 2 major challenges.
Okay.
First, how do you get an AI to judge the quality of code?
Right. It's not like a simple right or wrong answer.
The code has to actually work.
It has to work, exactly.
And second, how do you even begin to teach a machine to think like a programmer,
Yeah.
step by step?
Yeah, that's the big question, isn't it?
Yeah, so how are they tackling these challenges?
Well, they've developed this really innovative test case generator, or TCG.
Okay.
It's like an automated judge for the AI's code.
Interesting.
So based on the problem that the AI is trying to solve,
Mm-hmm.
the TCG will come up with test cases and see if the code actually passes.
So no more humans checking the code line by line.
That's right.
Wow.
And get this, on a data set of coding challenges called TACO.
Okay.
The TCG has an 89.2% success rate.
Wow.
That means almost 9 out of 10 times it can tell if the code is good or not.
That's impressive.
Mm-hmm.
But how do they get the AI to approach the coding problem in the first place?
So this is where it gets really interesting.
Okay.
They're using something called pseudocode.
Pseudocode.
Think of it like a simplified blueprint of the code,
Okay.
written in a way that's easier for humans and AI to understand. So the AI uses pseudocode to break down the problem into smaller, more manageable steps.
Exactly.
So-
So it first outlines the overall structure of the solution.
Mm-hmm.
Then it refines the pseudocode, adding more detail step by step.
Okay.
And finally, it translates that refined pseudocode into actual executable code.
So it's like the AI is creating a plan before it starts building, just like a human programmer would.
That's a great way to put it.
That's wild.
And what's really fascinating is they're not just feeding the AI pre-written code or pseudocode examples.
All right.
They're using a technique called reinforcement learning, where the AI learns by, well, essentially playing against itself.
Hold on, the AI is playing against itself.
Yes.
How does that work?
It's like giving the AI a coding puzzle and letting it try different solutions.
Okay.
So this is where Monte Carlo tree search, or MCTS, comes in.
Mm-hmm.
The AI uses MCTS to explore different coding strategies.
Right.
And if a strategy leads to code that passes the TCG's tests,
Okay.
the AI gets a reward.
So it's like a trial and error process.
Yeah.
But the AI is doing the trial and error itself, not relying on humans to tell it what works.
Precisely.
Okay.
And that's what makes this research so groundbreaking.
Yeah.
This AI isn't just mimicking human programmers, it's potentially developing its own unique approaches to coding.
Wow.
It's learning on its own, and that opens up a whole world of possibilities.
Okay, now I see why you said this was going to be interesting.
Yeah.
If AI can learn to code like this, what are the implications for other fields that require complex reasoning?
Right.
We're talking law, medicine, maybe even scientific research.
Absolutely.
Right.
Yeah, that's exactly what we'll unpack in the next part of this deep dive. And the thing is, this AI, it's learning to code,
Right.
but it's not just like copying human programmers, you know?
You're saying it's not just like spitting back code it's seen before.
Right. It's not regurgitating stuff.
Yeah.
The researchers, they actually noticed that some of the thinking tokens
Mm-hmm.
that the AI uses, they don't actually make sense in human language.
Oh, wow.
It's almost like it's developed its own internal language.
Really?
Yeah, like a more efficient way to represent the problem and the steps to solve it.
That's incredible. It's like watching the AI develop its own mental tools. This is a far cry from those chatbots that just rehash stuff from the internet, isn't it?
Oh, yeah, absolutely.
Yeah.
This is totally different. It gets to the heart of what intelligence is, you know?
Right.
Are we simply mimicking what we've been taught?
Mm-hmm.
Or can we create truly novel solutions?
Right.
And this research suggests that AI might be capable of the latter.
Okay, I'm officially hooked. So where do we go from here? What's next for this kind of AI?
Well, the paper outlines a couple of really exciting directions.
Okay.
The first is generalization.
Generalization. So meaning the AI could apply its system to thinking to problems beyond coding.
Exactly. Imagine an AI that could seamlessly shift between tasks,
Oh,
using its reasoning abilities to, like, help with scientific discovery 1 minute
Right.
and then writing a screenplay the next.
that would be incredible. An AI that's not just like a specialist in one area, but a versatile problem solver.
Exactly. A jack of all trades.
That's wild.
Yeah.
You mentioned a second direction. What was that?
Yeah. The other big leap is taking this AI out of the digital world
Okay.
and applying it to real-world tasks.
So this is what we touched on earlier.
Yeah.
You're talking about robots that can learn complex actions, AI assistants that truly understand our needs, AI that can interact with the physical world, not just data.
Precisely.
Okay.
And the paper hints at how recent advances in embodied intelligence,
Mm-hmm.
where AI is embedded in physical systems,
Right.
could make this a reality.
That sounds pretty futuristic. But before we get ahead of ourselves, didn't the research also mention some challenges that need to be addressed?
Yes, definitely.
Mm.
Not to rain on the parade, but yeah, there are some challenges, and they're not trivial.
Okay.
Remember that reward system we talked about earlier?
With the AI getting rewarded for writing code that works.
Exactly. The AI gets a virtual pat on the back for doing a good job.
Right.
Well, figuring out that reward system. That's easy in the controlled environment of coding.
Uh-huh.
But how do you define good behavior for an AI that's making decisions in the real world?
Right. With all its complexity and ambiguity.
Exactly. The stakes are a lot higher
Yeah.
if the AI is interacting with the physical world.
Yeah, for sure.
Okay.
It's not just about getting a line of code, right? It's
Yeah.
about making decisions that could have real-world consequences.
Exactly. And that leads us to this concept of system-to alignment.
System to alignment.
Yeah, which the researchers touch on in the paper.
What is that?
It's the idea that by encouraging the AI to really think through its actions,
Okay.
we can make it safer and less prone to bias.
Interesting.
So instead of just blindly executing instructions,
Mm-hmm.
the AI would consider the potential consequences of its decisions.
So it's like teaching the AI to think about the why behind its actions, not just the what.
You got it.
Right.
And that's incredibly important if we want AI that's not just intelligent,
Right.
but also responsible and aligned with human values.
It sounds like that thinking through process would require the AI to have a pre-sophisticated understanding of the world and how things work.
Absolutely. And that's another challenge that the researchers highlighted.
Okay.
It's called the environment state update problem.
Environment state update. Okay, you're going to have to break that one down for me.
Okay, so think of it like this. If you're teaching an AI to play a video game,
Mm-hmm.
it needs to understand how its actions affect the game world.
Right. It can't just make random moves.
Exactly. It needs to know the rules of the game
Mm-hmm.
and how its actions change the state of the game.
Right.
But modeling the real world, that's way more complex than a video game.
Oh, yeah, for sure.
It's constantly changing,
Mhm.
full of unpredictable events and nuanced social interactions.
So how do we build AI that can keep up with that? It seems like an impossible task.
It's definitely a challenge.
Yeah.
But the researchers, they suggest some interesting approaches.
Okay.
They point to recent advances in generative AI models,
Okay.
the kind that can create realistic images and videos. Right?
So instead of trying to program the AI with every single detail of the real world,
Mm-hmm.
we could use these generative models to create a kind of virtual sandbox for the AI to learn in.
That's a pretty clever approach. It seems like we're still in the early stages of figuring all of this out, though.
Yeah, we are. But that's what makes this research so exciting.
Okay.
It's not just about the progress that's been made, you know. It's about the possibilities it opens up.
Right.
It's a roadmap for the future of AI, where these systems could become true partners in solving some of humanity's biggest challenges.
But as we've discussed, it's a future that requires careful consideration.
Oh, absolutely.
We need to balance the potential benefits of this technology with the risks
Mm-hmm.
and ensure that its development is guided by ethical principles.
Couldn't agree more. And that brings us to a fascinating comparison that the paper makes
Okay.
between O1
Mhm.
and AlphaGo.
AlphaGo, the AI that mastered the ancient game of Go.
That's the one?
Yeah. I remember that AlphaGo was a huge deal.
Huge. It beats some of the best Go players in the world.
It was amazing.
What's the connection to O1?
Well, both AlphaGo and O1, they use this combination of imitation learning,
Okay.
reinforcement learning,
Mm-hmm.
and Monte Carlo tree search.
Interesting.
And it suggests that this blend of techniques
Okay.
could be a key to building truly intelligent systems.
So if we follow the trajectory of the Alpha series, which went from Go to protein folding with AlphaFold and coding with AlphaCode, where might O1-like systems lead us?
That's a question we'll explore in the final part of this deep dive.
So we were just talking about AlphaGo and how its success might kind of foreshadow where O1-like systems could lead us.
Right.
So what kind of future are we looking at if these systems just keep evolving?
Well, the research paper highlights two really exciting directions.
Okay.
First, there's the potential for generalization.
Generalization meaning the AI could apply its system to thinking to problems beyond coding.
Exactly.
Ah,
Imagine an AI that could just seamlessly shift between tasks,
right.
using its reasoning abilities to help with scientific discovery 1 minute,
Okay.
and then writing a screenplay the next.
That would be incredible.
Right.
An AI that's not just a specialist in one area,
Right.
but a versatile problem solver.
Precisely.
And the second direction is even more mind-blowing.
Yeah.
Taking this AI out of the digital world and into the real world.
That's right. We touched on this a bit earlier.
Right. You're talking about robots that can learn complex actions, AI assistants that truly understand our needs, AI that can interact with the physical world, not just data.
Exactly. And the paper suggests that recent breakthroughs in embodied intelligence.
Embodied intelligence. Remind me what that is again?
It's the idea of embedding AI in physical systems like robots.
Okay.
So instead of just existing as lines of code,
Mm-hmm.
the AI would have a physical body that allows it to interact with the world directly.
So we're talking about AI that can move around, manipulate objects, maybe even have senses like touch and sight.
That's the vision.
Yeah.
And it opens up a whole new world of possibilities.
Yeah, it does.
Imagine AI-powered robots that can assist with surgery or explore hazardous environments
Oh.
or even help us with everyday tasks around the house.
It sounds like science fiction, but it seems like we're getting closer to making it a reality.
I think we are.
Yes.
But as with any powerful technology,
Right.
there are challenges and ethical considerations we need to address along the way.
We've talked about some of those already, like figuring out the right reward systems, ensuring the AI can keep up with a constantly changing world, making sure its actions are aligned with human values.
All crucial pieces of the puzzle.
Yeah.
And as we move forward, it's important to remember that the development of AI,
Yeah.
this isn't a sprint, it's a marathon.
It's going to take sustained effort, collaboration, and a willingness to ask tough questions.
I agree.
We can't just rush into this blindly.
Absolutely. The stakes are incredibly high.
Yeah.
The future of AI, it's intertwined with the future of humanity.
That's a powerful statement. So what's the takeaway for our listeners then? What should they be thinking about as they consider the potential impact of all this research?
I think the most important thing is to stay informed and engaged.
Okay.
This is a conversation that we all need to be a part of.
Right.
We need to think critically about the potential benefits and risks of AI and work together to ensure that its development is guided by ethical principles.
It's easy to get caught up in the hype or the fear surrounding AI,
It is.
but it's important to approach this with a balanced perspective.
Absolutely. And that's what we've tried to do in this deep dive.
Right. We've explored the exciting potential of O1 Coder and similar systems.
Yeah.
But we've also highlighted the challenges and the need for thoughtful, responsible development.
That's right. This research, it's a glimpse into a future where AI could become a powerful tool for solving some of humanity's biggest challenges.
It could.
But it's up to us to ensure that it's used for good.
It's a future full of possibilities, and I'm excited to see where this journey takes us.
Me too.
And to our listeners, we encourage you to continue exploring this fascinating world of AI. Keep asking questions, stay curious, and be a part of shaping the future of this incredible technology.
That's it for this deep dive. Until next time, keep those brains buzzing.